It's Aziz Khan with you. Basically, a friend of mine, he requested me to guide him on how to choose radio equipment like antenna and the radio and everything else for a link. And I was thinking from many days to make a new course on YouTube and Udemy about microwave transmission, the technical part, I mean, the propagation part of it. So I thought this is a good time and this is a good start, I mean. So you can take it as the first lesson for that. So I have, you can say, kind of started making a new course. I will put it as a new playlist in YouTube and as a new lesson in Udemy, and I will go through the normal planning process and the technical details of microwave link, how propagation actually works, why we make a lot of things, I mean, in antenna, how we choose different type of things, and how basically the environment affects. So this is a kind of a start because of a question. I mean, I've started everything, so I'm kind of thankful to the guy who asked a question. So initially, this should be, you can say, a starting or a very simple introduction. I have put it very small, like an intro only. So I will tell only that how we choose a antenna based on what factors, like we have some antenna size, gain, antenna type, radius, trouble routing, XPD, beam width. But I will not go in very technical details of these things because I will cover them as different lectures in my next coming lectures. I mean, I will make it myself. But if you people can ask some questions, so I can at least try to take your questions as well. I can try to make it more friendly to you, or it may give some answers to some of your questions, because I cannot imagine all the questions which everyone has, but I try to impart whatever I know. So if you ask questions, then maybe I can add those in my lectures. But still, I have a lot of good material. I will make a good course of technical knowledge of microwave link planning. So in this one, I will just show you some antenna related things and then some radio related things on radio things as well. So hopefully I will break it in two different lectures and I will post them one by one, and this will become a foundation for my new course as well. And I will add, as I told you, I will add that course in YouTube as a new playlist, and in my Udemy, I will add it as a new course. So keep an eye on that, and I hope you should like it. If you have any question, you can ask. So let's start. So basically, I will take you through that. What are important factors? How, when we are choosing an antenna for our link, so on what basis do we choose that antenna? I mean, what is the reason behind that? So I will take you, or I will guide you to some of the things, because this is non-exhausting. There are many more things which hopefully when we will be covering it in our next lecture, then I will try to cover other things as well. So usually what we do is that we have this kind of antenna specification. It may be from any company. I mean, you can guess the company from the model name, but this is not important. Usually they have the similar structure. I mean, you have a frequency and other details on the top, and then here you have different frequency bands. So we will see that this band is also compatible with the radio as well, because that's why they are all ITU compliant. I mean, when we talk about the band, 6 gigahertz band, so it must start from 5.9 and go up to 7.125. So this is the band, but one band may have a different audio requirement. Even in antenna, they may have different type of antenna. I mean, it does not mean that one band should have exactly one antenna. Antenna should be one, but you will have to specify exact frequency that you will be using, because even in antenna they have some. But that when I will go in detail. I mean, I don't want to make you too much confused right now. But just remember that even the antenna model is same, but we don't have exactly same antenna for whole the range. Within the range, there are some small details which you should learn in my course and you should know as well. So if you see any antenna, it has a single or a dual polarization. So two type of antenna in every band, and then the antenna size determines the further that how much you can go further. Like you can have a 3 feet antenna, a 4 feet antenna, 6 feet antenna, and can have like here in the higher frequency you have a smaller 2 feet antenna as well. They don't have a 2 feet antenna in 6 GHz. So and they may have a 12 feet antenna as well, a specialized antenna, not for normal delivery, but for if you specifically ask, then they may provide you. So uh, okay, so you can see here that in the naming, like the number, first number, I mean, like this SC3, this 3, this number is the same as the feet. I mean, these are 346, 2346. Here you can see 2346. Then this is again 2346. So the first number here, it denotes the size. This model numbering is also almost similar in almost all of the antenna vendors. So you can have some idea from here. The next number is basically your frequency band. Like this is 6 gigahertz, so this number is 60. This is 7.1 gigahertz, so this number is 71. This is 10 gigahertz, this number is 100, 10 0. So this number and these numbers, they have a significance. Like in dual, you can see that is after SC there's a X. This is also you will see common in almost all vendors. X means that this is a cross polarization or a dual polarized antenna. So generally these naming are quite similar. I mean, they are not exactly same, but for all the vendors, these are quite similar, and you can get the idea from the antenna model that what kind of antenna it could be. So you can have some idea from these numbers. And then if you go further, you see the first number was diameter. Then we have a gain. Now if you see in the gain, like 3 feet antenna has a gain of 33 and 4 feet antenna has a gain of 35. So it means that a size change of 1 feet makes this almost 2.5 dB change here. This also has 4 dB change because here we have 2 feet change. From 4 to we go to 6. So from 35 we go to 39. So this is also you can make a kind of when you will start using, you will get some idea that if the size increases, so antenna gain also increases. But this is because this is not the only thing. When we go further, there's a 3 dB beam width. Now if you see, this goes down with the size. So something goes up, but something goes down as well. So having a large size is not always good. Even if you compare it, if you go to the last, which is very simple, I mean, the weight goes up. 3 feet antenna is only 20 kg, but the 6 feet antenna is 90 kg. Huge weight. So it will create a huge loading on your tower. So you have to take care of, you have to think about everything. It's not that you make a decision based on only one thing and you made a decision and then you came to know, oh, it is making these kind of problems. So, and that's why this is not very straightforward. Generally, companies, they have a planning guidelines where they tell you that, okay, in what kind of link you should put what kind of things, but it's a lot on the person who is doing, how many antenna you already have, how much tower loading is already there. Sometimes you need a 1.2 meter antenna, but you have to put a small antenna because of other reasons. So sometimes you are being constrained because of some reason. So you have to know everything. Okay, after that there is voltage standing wave ratio. So this is for the coupling of the antenna. When you couple it, it will give you a 1.38 of VSWR. The people who are in the field, they know it much better. VSWR makes return loss value automatically. These two values are, I mean, they are from each other. I mean, like whenever you will see 1.38, you will see 16. Whenever you put 1.3, it will be 17.7. It will always be there. So because they are calculated with similar formulas, so you have to match these. When you are matching your power, you have to take care of VSWR. The people who have worked in GSM in the field side, rollout side, or whatever, they know that there is a VSWR meter who can gauge the VSWR. So you have to match it somehow. Then we have cross polarization. They have provided a number in single polarization as well. Generally, in the single polarization, because you have only one polarization port, so you don't take care of it a lot. But in the dual polarization, this is very important. Usually, you will get it 30 everywhere, and 30 is a good number. It means that you have two ports, one is horizontal, one is vertical on your antenna. there is a mechanical difference. I mean, anything which is put on the vertical, it you will receive some part of it, 30 dB low part of it on the horizontal as well, and vice versa. Whatever you have on horizontal, 30 dB low will go into vertical as well. So the antenna will give 30 dB separation, and then the IDU will also give some separation that we will discuss in the IDU part. But this is very important thing, cross polarization, especially for the dual polarized antenna. IPI was not there initially, but it is a good thing. I mean, you can see it's only in the dual polarization. It's a interport isolation. So this is also another number, that whatever is coming on one port, 35 dB below will be coming on the other port as well. So now it is not because of the polarization, it is a port isolation, that how much the ports are isolated electrically with each other. So how much signal from one port can go into the signal of other port. This was related to polarization, and this was related to actual port. So somewhat it becomes confusing as well, but when we will go in the detail, I will try to make it more simple in my next coming lectures. F oblique B is the front to back ratio. So whenever you put an antenna, I mean, so for example, this is antenna and it is transmitting in this direction, but some signal will be received in the other direction. I mean, like something you are getting on the front and something you are getting on the back as well. And there's a difference of 60 dB. Like for example, if you are sending 10 dB here, then minus 50 dB is on the back side. So this is front to back ratio, and it is very important when you are putting antennas back to back because of any reason. So you must know that if you're putting back to back, so anything which is going on one side, it must be received on the other side as well. Yes, it will be 60 dB below, but it should be there. Then you can have a fine adjustment. Like if, for example, if this is your antenna, I mean, it is in this direction, so you can tilt it in these ways and up and down. So you can basically tilt it in almost any direction, but this tilting in up and down, it will be 15 degree, and right left it should be again be 15 degree. But for bigger antenna, the value is small, you can tilt less. And this is also because of this 3 dB beam width, because that's why the bigger antenna is a bit difficult to pan, because you cannot tilt it a lot, and the beam width is also shrink, small beam width. So, and maybe I missed the beam width part, but I will go in detail of all of these things in my later. Beam width is basically that how much is when your ray is coming, how much sharp it is or how much narrow it is. So it is called 3 dB beam width. You can see that the bigger antenna has a bigger beam width, and a small antenna are more narrow, more sharp. I mean, so panning to small and bigger antennas is a bit different, and panning to small antennas is a bit easy, because here the beam width is also bigger for the small antenna, and you have more degrees to tilt the antenna. But here the beam width is also small and the degrees is also small. So these are some things that you should have some idea of. Then we have the operational wind speed and survival wind speed, that how much wind it will work fine. It will not move a lot. It will not be broken. Some part of it may not be broken. This I will show you in my next slides. And then the weight, as I already talked about, the weight is also important. So let's go to the next slide. Here we have some antenna mounts and kits. If you see here, this is the antenna. This is called the antenna shroud, this white thing. This white thing which is covered on from the top, from the front side, it is covering it. It's called radome, because this is the mount kit and this is the antenna. When we will put a ODU on the back of it, so the actual antenna, or I mean whatever is feeding, I mean the feed horn should be coming from here, from this circle, from this hole. So this radome is because if there is any rain or anything, so the water, or if there is the area has snow, then the snow may not accumulate inside the antenna dish. Otherwise, if it is fully gone inside, then it can even damage the feed horn and damage the actual antenna. So that's why we put a radome. And this survival operational speeds, these are for, I mean, if there is a very high rain and wind, then this can damage your radome. And if the radome is damaged, then sometimes we have seen that, for example, the radome is damaged and some birds, they make a nest inside, and then you came to know that the link is not working, and you go there and you find that there's some eagle sitting and it has made its home. Your dish is working as a home, so you can have these kind of issues as well. So that's why radome is very important, so that it don't allow anything to go inside. Then here we have different wind kits. If you see here, this here if you see, this antenna is connected with this antenna mount only. But here if you see, there's another rod, one extra rod. So you tie the antenna with a pole and then you tie it with something else as well, so that you make that, so that antenna don't shake. I mean, you make the shaking a bit lesser, because when there is too much wind, then antenna may start shaking, and this shaking, because sometimes it may be too much that antenna may lose its angle. It may become a bit tilted, and it will, like for example, the it will be there should be a lot of errors. I mean, and when you go to see, you will find that antenna was tilting a bit during the harsh weather. So to make it stable, you put the wind kits, you put one bar, you put two bars, and these are some things which are used to mount these kits. I mean, so these are different kind of things. I mean, you should have some idea of all of these, so that you can, when you are planning, then you can make a stable link. If you know the area is too much windy, then you should have additional perimeter sway bars, so that antenna don't shake a lot. Then these are different kind of accessories which we use. So this is the antenna. This is some antenna, and this is, you can see, this is the front side. This is the red arm, and this is the antenna mount kit. This is put on the back of the antenna, or sometimes on the side of the antenna, depending on, like if you see this one is a E-band antenna, so it is mount from a side. The audio will go on the back of it. This antenna is quite similar to this one. So this is almost the same thing. It came from the back of it. So if you see here, you can put, like for example, one ODU on this side, one ODU maybe on the other side. This one typically has three ODU. I can see from here, one is this, and one maybe this one. So you can have multiple ODUs also connected to the same antennas. Like for trunk radios, sometimes you have 8 ODUs. So there is a full fixture where you put all the ODUs, and then because the copper cable which is coming from the IDU, it terminates on the ODU. So whatever comes out of the ODU is taken through a waveguide like this. This mount also works as a waveguide. There's a waveguide inside this mount. So when you put the audios just on this mount, then you don't need a waveguide, because the audio is mounted on this fixture and this is mounted on the antenna. But for example, don't have a picture right now, but for example, if you have a audio mounting structure, and then you mount that structure somewhere, and then you have to take this kind of elliptical waveguide from the mounting up to the back of the antenna, so that you can connect all the ODUs. For example, there are 8 ODUs on a ODU mount, and then you have a elliptical waveguide which will go from this mount to the back of the antenna. So these are different kind of connectors. This is a twistable. So this is also corrugated. So it can also, this is also a bit flexible. There are different kind of things that you have to have some idea that how the installation is done, what kind of equipment are generally put. So this is just to give you some idea that when you put an antenna, the antenna should have antenna mount. Depending on the mount, it may have some elliptical waveguide, some twist flicks, some different kind of connectors and everything. So uh, I will keep the antenna and radio separate, because I feel that otherwise it will become a very long single video. But so when you are planning for a link, let me show you it on the. So this is, for example, this is a example link. I mean, I don't have filled a lot of things in it, but I just have filled the radio and the antenna part of it. So you can see that whenever you plan a link, What happens is that path loss gives you that what should be the free space loss. It told you that 114 is the free space loss. So you must overcome 114 dB loss if you want to connect this point to this point. So based on that, we choose the antenna and the radio and everything. Like for example, we choose this antenna. This antenna, if you see here, from the name is A13S03. 03 means it's a 3 feet antenna. Hopefully diameter is zero point 0.3. Okay, here this maybe this diameter should be zero point 0.3 based on this. And so antenna gain is 30 dB. So we have two antenna 30 dB gain from here 30 dB. So 60 dB gain should be compensated by the antennas. We have to take care of 44 dB gain as well. Okay, I hope you get some kind of idea. I will make some more detailed videos, but just to tell you that whenever you plan a link, you plan the equipment based on the free space loss that maybe you will be getting. So on the size of the link, like it's a 2 kilometer or 5 kilometer, 10 kilometer, you put different frequency and different size of antenna. Like for a small links, you put a high frequency and a very small size of antenna. But for very long links, you put a low frequency and a bit higher size of antenna. But this, how do we say this is lower, this is higher? How do we say this size is low, this size is good, this size is bad? We learn it with time and we learn it by not only with time, we can learn it by making some example links and see the behavior. So I will in my coming lectures, I will show you that how we do that, how we put something and how we think that why this one is better or why that one is better. I will make different configuration for the same link just to show you that okay, why we will put some of the link. I mean, why will you put one specific link? Why not some other link? So this we will learn, but just to give you some idea that the free space loss, your antenna gain, your system threshold, these are important things. Like if you see here, this is transmitting with 27 dB and receiving at minus 25. Okay, so 27 dB is transmits and these are 60 dB antenna gain in between and the free space loss is 114. You can easily calculate it by yourself as well. That okay, I start from 27, I get 60 dB added because of antenna, so it becomes 87 almost or 88, and then I removed 114, so I get minus 25 as the answer. I will show it to you in by doing some mathematics as well, that how we do these calculations which the path loss does for us on the back end. I will give you some idea so that you have at least some background idea. So if you are receiving on minus 25 and it's saying that your thermal fade margin is 61. So the difference between these two is basically because this fade margin comes from your received threshold. So it means that your equipment has a threshold of almost 87, because if I take 61 and I remove 25, I mean I minus 25 from it, 25.26, I get exactly 87. So let me go in this radio. So you see here the received threshold is minus 87, exactly the same number which I was telling you. So we can get these numbers mathematically. I mean, I will take you in detail of all of these just to show you. So the point of showing you here was that why we do. I mean, we put some antenna, we put some radio, and we see these figures. I mean, where they go? For example, if the company wants us to have a thermal fit margin better than 50, then this looks to be a good. It has a thermal fit margin of 61, which is way more better. But this is not the only thing. There are many other things as well. So hopefully we will learn all these things one by one. I will this video here because then I will make the video on the radio equipment, and then we will go further. I will add more and more. So see you in my next video. Goodbye.